Okay, here we go with a question all about albedo and emissivity. As ever, press pause, try the question, and then hit play to see if you agree with my answer. All right, so we've got instant, radiant, and reflected intensities. One thing to note, we've got all of them adding up to the right numbers. We've got 500 in, 350 and 150 out, and 500 in, 320 and 180 out. They add up together. We want to know which region has the greater albedo and which has the greater emissivity. And we've got a series of combinations here, x, x, y, x, etc. Now I think initially, if I were in an exam and I was trying to rule things out, I'd probably be tempted, without even reading the question, to get rid of A and D, because A and D suggest that both things at the same time. And I think we're probably aware, hopefully, for the basic understanding of these two quantities, that it can't really be possible. However, we'll check this just now. Let's look at these two quantities. Our albedo, to start off with, is the intensity of reflected radiation to the intensity of incident. In other words, it's a measure of which surface is good at reflecting. Similarly, our emissivity is a measure of how good we are at emitting. So in other words, the more we reflect, we're going to have a higher albedo. The more we emit, we're going to have a higher emissivity. That's the basics of this here. Okay. So in terms of comparing those two things, we look at regions Y and X. You notice that region Y reflects more radiation than region X, and therefore its albedo is going to be greater. Okay, which is why we can get rid of those two answers, because we expect albedo to have the greater, Y to have the greater albedo. Right. Similarly, in terms of radiated intensities, X radiates more than Y, which means that X is going to have a greater emissivity, which is why the answer here is B. I'd be delighted if I had this question coming up. I'm sure you'd be too.